Okay, so at this point in our parabola exploration, we're at the point where they want us to be able to know how to find the vertex form of the parabola. So they want us to be able to convert a standard parabola into the vertex form of the parabola. One thing that's interesting about the vertex form of the parabola is it helps you find the vertex when the parabola isn't centered at 0. And in this form, it's also easier to solve for x than what it is in the standard form. We have to solve the equation. Okay, so the method that we use to get the parabola in this form is called completing the square. The important thing to note is we're talking about as it pertains to trinomials. We know, for instance, if we're talking about x squared minus 9, if we factor, we get x minus 3, x plus 3. But we're not talking about completing, this is called a difference of squares. If I had set to 0, this tells me solve for x. And so I would factor to find this out, but this is a difference of squares, and it's not completing the square. Because when we're talking about completing the square, we're talking about a perfect square trinomial. Let me write some down here. So if you were to ask to factor this, I think you guys factored basic trinomials, quadrics. We know that the x's are positive. We have put our x's in. Both signs are positive, so this would be positive. Two numbers whose sum is 10, you have the same two numbers whose product is 25, and that would be 5. The only difference here is, notice this is a perfect square trinomial, meaning this whole term here, at least the left, the x squared and the 25, are perfect squares. You could write 25 as 5 squared. And the reason we know 5 works, because when we follow the first law, the sum of the two numbers have to equal the middle. We know that that's true. So since we have it in this form, the general form, we factored it out and we found this. We noticed that the terms are, one of the terms is redundant, because there's only going to be one answer. X equals, if you solve for both of these, you'll find that x equals -5. So that just means that at the end of the day, it's not going to touch the x-axis at 2 points. But since we have it like this, we can write it as simply x plus 5 squared. Okay, so let's do it. Come on. Okay, so let's look at another one. So we have x squared let me see here. Plus 7x plus 12. Now see, if we had to factor this trinomial, we could look at it, put our two parentheses, throw our x's in, and both signs are positive, so it'll remain positive. And I know the sum of 4 and 3 gives us 7, and the product of 4 and 3 gives us 12. But notice this isn't a perfect square trinomial. It is a trinomial in factored form. But since it's not a trinomial, a perfect square trinomial, we couldn't write it as a plus or minus b squared. We can only do that with a perfect square trinomial. Let's see here. X squared plus 8x plus 16. If you look at this right here, two numbers whose sum is 8 and the same two numbers whose product would give me a perfect square. So we can see 4 would satisfy this, right? If we had factored this, it would be x plus 4, x plus 4. So, and because we can factor it this way, notice these terms are the same. So since it's a perfect square trinomial, we can write it as x plus 4 squared. Okay, let's look at another one. X squared let me see here. Plus 20x 20x plus 100. So again, let's take out this 100 for a second. I'll have him go over here. Let's replace this with a blank. Okay, so I could say what two numbers whose sum is 20 and the product of those two numbers make this a perfect square. Well, if I look at 10 10 plus 10 is 20, and the product of 10 squared is going to give us 100. Because if I look at this, for example, if I do another one, let's see. See, if I factor this out, it's going to be x's x plus 5, x plus 4. So the only reason I did that is when I put that 100 in there, there is going to be a distinct value, a distinct product of numbers that will satisfy this middle part here. Okay, so I'm going to conclude on this just because it's pretty simple. Completing the square is a method we use to find the vertex formula of the parabola. In this case, what we've been doing is we're just factoring trinomials. If the trinomial happened to be a perfect square over here and satisfied the middle condition, we could rewrite that as, I'm just going to a plus b squared. And that can only be written if you have a perfect square trinomial. So you take the perfect square trinomial and now you turn it into a binomial squared. The only, again, the only real value to that is you can put it in vertex form to try to find the parabola, the vertex of a parabola, not centered at the origin. And the other advantage to completing the square with an equation is it's easier to solve for the x's. So that's basically what completing the square is, the basic part of it. Now, when we actually do it as an equation to find the parabola, there'll be one other step. That's it.